Hi everyone, Rob Mansfield, Dmitry, we'll do our proper introductions as we go through the presentation. So, as has been mentioned, I'll get out of the way of the screen. So, we're Accenture and we're actually a little bit of Accenture, which I'll talk to you about in a little bit as well. So, not just the people that walk around throwing big words around, I'll try and keep the words short and very normal over the course of this presentation. We are going after generative AI specifically, more than happy to chat data science to anyone else in the room. That's what we're going for. Now, Dmitry and I have been working on Gen AI projects for a little bit now. There's been a few things that we've delivered, and we've found some common themes that we have in conversation with our clients when we go in about being actually ready for this stuff. Like, have you got all the bits and pieces arranged so that we can actually come and deliver some value for you? And we've started to assess a little bit, we've started to build a little bit of a score sheet. Not finished yet, you guys are our test pilots. So please feel free to ask as many questions as you want on slide out, and I will make sure Dmitry answers all of them for you. But we'll see how it goes. So this is me, Rob Mansfield. Well, that was me 15 years ago, but I still look something like that. And of course, the Gen AI presentation, this is me riding a unicorn in outer space with a lightsaber. It just has to be done. Like, mankind's got an infinite ability to take serious world-changing stuff and be ridiculous with it. Speaking of which, I'm going to open up a little bit of corporate marketing, just because we, Accenture Next Gen Engineering, are kind of new kids on the block here in Manchester, so I feel it needs shouting about a little bit. Those that knew Infinity Works, many of us are now part of Accenture Next Gen Engineering after the acquisition. And it's our remit, it's our kind of scope to bring together all the bits of Accenture and bring that kind of mindset of product first delivery of actual value quickly to the lumbering behemoth that is Accenture. We have mixed results, but in general, we can get people from 0 to 80 using our teams and our cross-functional delivery model, and then we can go to this wider bit of business and say, right, we need the extra 20%. We're going to bring that in, we're going to apply our delivery frameworks to it, and we're going to get some value out the door. This is our raison d'etre, which is very long and wordy, and I don't like it, so I'm going to go with this. We're this guy here, Chief Miles Edward O'Brien. I know this is a DS9 photo, but he was in Next Generation, so I'm going to run with it. We're the engineers. Like, someone comes to us with a problem, we'll go and talk to them about the problem, we'll arrange all the other clever people on the ship, and we'll work out a way through that problem. That's who we are, kind of get it done before the Borg assimilate everyone. And we do this through a cross-functional set of specialisms, so we sit in data, but we also have engineering, design, delivery, all those things under one roof. So we all used to work with each other, we all know each other. But we are the data people in the organisation. And we do all of it, so cloud migrations, data science platforms, into ELT pipelines, I have written ELT. And of course, generative AI has fallen into our remit as well. We had AI in our title, so it's kind of a natural progression for us, and that's why it's fallen on us. That's the end of the corporate marketing, so please feel free to zoom back in, pay attention to what I'm saying again. I apologise for that, I'm contractually obliged. Got Dmitry.
Yeah, this is me. Hello, I'm Dmitry, Senior Data Engineer at Accenture Next Gen Engineering. As you can see, I'm absolutely obsessed with Paisley. This is all
it
the
doesn't
time.
come out well on the
No, it doesn't. I was
presentation.
hoping for a better project. Anyways, but I have to do the obligatory thing, ChatGPT, do the thing. There you go. You can see the Paisley. Isn't it beautiful? And I look stunning. Absolutely stunning. Anyway, so Rob and I, yeah, sure, why not? So Rob and I are here to take you through this kind of first iteration, let's call it, of our Gen AI readiness for business. And we're going to cover data governance, realistic expectation, user-driven solution, LLM ops, and all of that we're going to run through in hopefully 20 minutes. We'll see what happens. But to start all off, we're going to have a chat about data governance and actually data itself. So the first kind of major decision you have to make is, how sensitive is your data? Is this something you're happy to send to a third-party provider, such as OpenAI or, for example, Anthropic, using one of their APIs? If that's the case, that's the best and easiest solution. You know, if you want a bit more control of your data, you can have it all in the cloud environment. You host your models in the cloud environment. And if your application is very, very sensitive, which I would argue there's very few cases where that would be applicable, you can of course run your large language models on premises by hosting and orchestrating them there. That's a lot of headache right there, but it's worth it for some applications. And before I proceed, anything that you send to ChatGPT is stored and trained on. So not even on the slide, but something to keep in mind on. General governance strategy, have a good kind of policy, align your policies with your governmental requirements in general. So for example, GDPR, that's always good practice. Have a good data handling framework, resolve any privacy or security concerns that might arise. And more importantly, the actual leadership roles. Champion your data. Be the champion of your data within your organization. Make sure that you set out your data practices, your governance, so that the rest of the organization follows you throughout. And then I really thought of not including the slide, but LLMs are no different to any other critical infrastructure. So access management is standard. The less privilege, the better. Detect, prevent, and alerts. Make sure you have all that set up. And same with policy auditing. Have this in your belt before you start, creating any generative AI solutions. And that is the first tick in our checklist, which now Rob is going to have a look at.
I'm going to try and use the keyboard.
Oh, you're going to try to use the keyboard. Go on then.
So, okay, first step. There's loads of things you can do with Gen AI, and we can argue quite a lot about whether or not something's a Gen AI problem. But if you're a company that's developing things, this is your low-hanging fruit. Developers in the room, have you been using some sort of generative AI to help you write your code? Yeah? It's cool, isn't it? I was trying GPT-01 the other day. It's fantastic, far better. You no longer have to copy and paste into a different window and say, will this actually run? Does it make sense? It does it for you. It's a really nice interaction. And of course, if you don't want your code going to America, then you can use locally hosted models. You can use Alias Q, Code Whisperer, Copilot. Tools abound, and they're very, very helpful as a wingman. And there's a lot to be said about what it can do for early career developers and whether or not it's harmful or helpful to their development and how much work you then need your seniors to do. And that's very much a conversation for over a beer. But I think we can also stretch out how it can help aside from developer work. We can go and look over here as well. So every single bit of kind of your software development lifecycle can be enhanced simply by having someone to sit on your side and be a rubber duck that knows things, or is able to go and reference your code base or look at your requirements and assess them for you. So again, very low hanging fruit, and you can do it with a ChatGPT window or with any other tool that you care to use. So I go for this first, it's just easy. People quite often say, isn't this expensive? I'm going to have to give every developer a ChatGPT license. It's going to cost me an absolute fortune. It costs you like $10, $20 a month for base policy. How much do you pay your devs an hour? It is very easy to make money on this kind of thing, simply by unlocking greater efficiency. If it's a couple of %, you've actually made a profit on it. Just as with intimators, always read the small print, what's happening with data, who owns the copyright, that's a big one. That's still a bit tenuous, technically, if it's not trained on your own stuff, someone else owns the copyright. But that's also how Stack Overflow works. And I shan't ask for a show of hands as to who has ever copied and pasted code from Stack Overflow, but just be aware of it. I haven't, I'm a professional. So that's two.
Realistic expectation and use cases. So, and I'm really glad to hear, and there's been mentioned a lot today about what are the realistic expectations from generative AI and the use cases for it. But in general, to simplify it to 3 points, the strengths for generative AI are unstructured data, or processing unstructured data, and specifically natural language processing and contextual understanding. These are the 3 key points that if that comes up, that is a natural, in most cases, natural fit for generative AI. There are exceptions, which we won't go too much into. And the use cases really do kind of derive from those, from those strengths. It's content generation, data analytics and insight, customer experience. Maybe you can have a chatbot that helps you customize a product, for example. Operational efficiency, which was discussed as well. It is insanely powerful tool to automate a lot of these ops, kind of, I guess, back of the office tasks that, use natural language. Software development lifecycle. If you're not using Copilot or something similar, you're already behind. You're already not taking full advantage of what's out there. So please, 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 if you can, and obviously considering data governance, do use it. And there are many more potential use cases. We cannot list them all. A lot of them can be experimental, but most of them would again go back to the strengths. But it's also important to consider what it is not good at. And we've got an example here, right? Although one can do this. This was put together just before one was released. Anyway, it can get expensive really quickly, as was mentioned before. So do keep an eye out on your spending. There is a chance of hallucination. So there's a chance that it will produce something that is not right or is not expected. Although there are ways that you can engineer the system in such a way to mitigate that risk to, if not zero, almost zero. And it's not suitable for all problems. As mentioned before, some things are just not for generative AI. There are much better algorithms, much better models you can fit from just general bog standard data science. God, I never thought to say bog standard data science, but there you go, yes.
It's happened.
It happened, yeah. And probably the biggest limitation, it requires a lot of specialized infrastructure. Vector databases were mentioned today. That is something that is part of this. LLM ops, which Rob will go into in a second. There's a lot that goes into running a generative AI application, and that kind of, in a way, limits it. So keep these in mind as you're considering whether Gen AI is the right fit. There we go. We're flying through them. 3 out of 5. Go on, Rob.
Okay, so first of all, I'm going to do a soft apology for the phrase LLM ops. I didn't invent it. I did hear it on a podcast, and I was like, actually, I quite like it. So I'm going to run with it. I think it does lean us into that kind of ML ops, like DevOps kind of mindset. So I'm just experimenting. But if you've ever done a data science pipeline, there's not masses of difference here. You are still experimenting. You are still validating. You're still monitoring the prediction process after you've deployed the stuff, because you're not entirely sure what it's going to do, and you still have to validate it against kind of a known truth most of the time, so that you can be sure that it's doing what it's supposed to do. And all of this brings you back to the old world of data science in one way or another. Just as an example, so I've stolen this from AWS. I'm just going to go out there and say this is from AWS. I'm sorry, it's really good. So AWS, if you use Bedrock, you've got a massive number of these base models you can use, and each of them is good at their own thing. So if you need to pick which model is best for your problem space, you've got to experiment. And again, this is exactly like the data scientists used to work. Is this a boosted tree problem? Is this a regression problem? You've got to look at your data, look at your problem, look at what you've got available to you, and make some choices as to the way to go through it. And all of this is part of that kind of exploration and experimentation framework to get you to something that actually does the doings. You then need deployment. You need that deployed thing to be scalable, you need it to be secure, and you need it to be versioned as well. But one of the key things for ML ops was like, you should be able to go and train the exact same model you trained a year ago on the exact same data and get the exact same results. I don't think that's necessarily kind of invalidated by these changes. You need to know what went in, what you did, and what came out, so that it's replicable and explainable when it flows up in someone's face. And that's just good practice. We all do these things, don't we? To varying degrees. But like, make sure you've got your infrastructure as code, your CI/CD cell. Make sure your code's good and tested. Maybe not unit testing, but you can still test an LLM. You can just vector encode things, do a diff, or you can get human beings to look at it. Or you can get it to check itself. There's ways to do it. And you just have to build it into your kind of productionization and development pipeline. And we should monitor, we should alert.
Yeah.
All just software development good practice. It is still valid. It's just a slightly different flavour. and then continuously improve. There's no reason that you can't adopt an agile framework. The feedback mechanism might be a bit longer, it might be a bit different. You can do it, and if you don't do that already in your organisation, if you're still doing waterfall stuff, then you will struggle with some of these concepts and you implement them IRL. So you need to make sure these things are in place. Again, a shamefully stolen art diagram, all mine under NDA, so I apologise. But the data scientists in the room will probably recognise this. Like, get your data in, DETL or ELT if you're being a bit more modern about it. Then do your annotations, do your labelling, get your feature store set up, and then get human beings to do it. And then you've got some sort of pipeline that you can train, you can optimise, you can monitor, you can deploy, and you can run all your data science stuff. But there's easier ways to do this in the first instance with things that aren't LLMs. So maybe think about what your process is and make sure it's right for what you're trying to accomplish. How are we doing for time? Are we out of time?
Just over an hour you've been going. So.
Good, excellent.
Right, user-driven solutions. So, as with any product, it's important to really focus on what the user really needs. So, user research is as important as ever in this case. So, really do try to identify what the true problem is and how you can best help them. Do not just try to fit a solution or here's Gen AI, here's a cool thing that we can do for you. There's no need for that, right? You're just going to be wasting money, engineering time, and I don't know, just embarrassing really. Agile methodologies, enable swift adaptation. It's really good to continuously check in with the users and see how they're actually, is this what they're expecting? How can we change the user experience for them? Is the output of the solution actually solving their problem? Again, that kind of comes back to tailored solutions. Really shape the solution to the problem of the customer. And at Next Gen Engineering, we approach this with kind of these 6 steps: align, discover, define, MVP, and develop. In an align, you get everybody on the same page. What is the problem we're trying to solve? Why are we all here? In the discovery phase, we all try to find out all the hidden things that there might be with a particular problem at hand for a customer, and what are we actually going to be potentially building. In the define, we drill even further into what we've discovered during the discovery process and how and what we're going to build, how we're going to solve almost subsets of problems within this one bigger problem. And then obviously there's an MVP, or in the case of generative AI, I like to refer to them as POCs. If it's a common use case, I would argue there's no need for a POC, purely because you can see generative AI solutions already being implemented as chatbots. But if it is something quite experimental, 100% a POC is needed. Maybe generative AI is not actually going to solve your problem. And then finally, development. And this, it looks linear, but it is a constant iterative cycle that we approach together with the clients to make sure that we're actually solving their problems as they want us to. Informed decisions. Align your engineering to the problem at hand. Do not just use cool tech because it's cool. As much as I like cool tech, sometimes, again, you don't need to. Apply best practices for generative AI, pretty much what Rob and I have been talking about today. And scalability. There is always potential for future generative AI, especially now that we're discovering what it can do. There is possibilities that further down the line there would be a particular use case for your business. So keep that in mind, that you might not need a generative solution now. In the future, you might want to be prepared with your data and actually everything that you covered really today to make sure you can approach it. And then finally, again, reiterating the user-centric nature of it. Talk to your, to the clients, to the user. How do they interact with it? Optimize the design specifically for the use case, specifically for the user, and robust data platforms. That's a given. Develop systems to support and make sure that they actually support and not just there as a cool, nifty thing. But sometimes it can be. And that brings us to the end of the checklist, although we do have a little bit more left for you in store.
I'm not sure how, I think we've probably overrun. We've waxed lyrical far too much.
Shall we? Got time? You've got to take 5 minutes tops. Well, applying this all in practice, we thought we'd share a project that I worked on about half a year ago. A client came to, obviously this is all under the NDA, so we had to be quite imaginative with how we're presenting this to you, so it's not necessarily what it was, but close enough. When a client approaches and say, hey, Next Engineering, I want to be able to analyze unstructured data and trace back supply chain carbon emissions. What is that? In a nutshell, they had a lot of unstructured data. That might have been Word documents, PDFs, so on and so forth. And they really wanted to trace back the carbon chain of suppliers. Where is all the carbon coming from? Because most of the carbon is coming from the supply chain. 90% of it, to be precise. So in today's world, it is quite important to do that. And at the moment, it was taking them weeks to months to put together a report on a client of theirs. And they thought, well, there's all of this unstructured data that we're manually processing, we're manually looking at. What can we do? And this is where we came in and said, well, let's try and resolve this. Right, so this is what we put together, and I'm going to cover this step by step. So first of all, software development lifecycle. From day one, we adopted Copilot. It was relatively new at the time, and Accenture had questionable, are we allowed, are we not? But we've decided to, and we've got proper permission, so we went on and actually used Copilot from day one to see how it affects our development, but also, it actually just sped everything up. It accelerated our development. We then focused on data and what data sources they had, and there was a lot of data. There was unstructured data that we had to index and vectorize and store in vector stores. There was a lot of relational databases, relational data that we had to ingest and then use as a reference point to compare all the unstructured data to make sure that unstructured data actually is valid. There was external sources, third-party, let's say APIs or external databases that we also had to account for. And we had some internal system databases for our own kind of engineering. In terms of engineering and LLM ops, we've had a very simple LLM ops infrastructure set up for us, as this was more of a proof of concept at first. And in terms of engineering, we again applied best practices to make sure that our backend was there to support the Generative AI solution. And you can see there's a lot of kind of subsystems of agent orchestration, management of internal databases, and that's probably the most important one, data cross-validation. As the client, we really wanted to make sure that all the data that we've kind of discovered from this unstructured data was cross-validated with other sources from structured part. And we built a solution that was able to do some cognitive reasoning, utilize different tools. So for example, if it needed to, let's say, go calculate something, it would go out to a separate call to a different system, because generative AI models are not particularly good at calculations. Well, until O1, or at least, anyway. So there's a lot of kind of, I guess, call-outs to other different subsystems that this agent network could utilize. And in terms of the user experience and focusing on the user, we really worked closely with our client in the sustainability sector to make sure that we delivered what they really needed, which was, first of all, trace back of sources, so they could quite easily have a look at where did this data come from, and that would actually point them not just to the document, but to the page and paragraph of where this came from, which kind of opened up this traceability of data within all of this unstructured mess, let's call it. And this system kind of provided a supply chain emissions at a glance view, so the client could kind of go in, look at the data, look at this shiny front end that was actually behind it. There's quite complex interactions happening powered by GPT-4. And at the end of it, it allowed the sustainability consultants, who usually spend weeks and months to scour through this data, well, just actually focus on the actions rather than putting the report together. And the impact out of that was reduction in processing time from weeks to hours. Obviously, this was kind of cross-validated together with actual sustainability consultants. And again, I'm a massive supporter of having a human in the loop in the right places, especially when you want to make sure that you know, the data is correct and the output of what you get is correct. And more importantly, which was the big success of this, is it allowed sustainability consultants to actually focus on the action rather than spend time scouring data. And that brings us to the end.
Yeah.
If you have any questions, we're going to be hanging around. Do message Rob. He'll probably point you my way if it's to do with generative AI. But we're happy to chat.
Yeah, that's my LinkedIn. So if you are interested in chatting about any of these things, just we are also hiring engineers and data people. So take a photo, look me up. Significantly more cameras that time, I know.